Hi, Tor Lacey here with a lecture on glaciers and glacial landform features. Some learning objectives include describe the geologic work of erosion and deposition done by a glacier, identify and interpret erosional and depositional landform features in photographs and topographic maps. Note that there are a few other learning objectives listed on the syllabus that you will address through your textbook reading and laboratory reading and activities. Glacial erosion and deposition has created very distinct landforms in mountainous regions and in the higher latitudes of North America. These landforms are still geologically new, having been formed during the last ice age over the past 2.5 million years. Two types of glaciers are recognized, though your textbook discusses a few others as well. The first that we'll discuss in this lecture are alpine glaciers, also called mountain valley glaciers because that is where they are found today. The second are continental glaciers because they are not contained in a single valley, but instead cover a significant part of a continent. Here's a photograph with another example of an alpine glacier. This is the main glacier here, with some tributary glaciers contributing ice to the main or trunk glacier there. Continental glaciers, also called ice sheets, cover Antarctica and Greenland today, but they were more extensive in the recent past. Here's a photograph of Greenland from space. And this is what Antarctica would look like, all covered in ice there. Let's compare glaciers versus streams. With a glacier, gravity is pulling the ice downhill very slowly. They're thick, hundreds to thousands of feet thick, and they are the most powerful erosional agent. They are only found in very cold places or high up in the mountains. Streams also move downhill under the influence of gravity, but they move significantly faster than glaciers do, and they're not as thick. The very thickest river is about 800 feet deep, but most are just a few feet to tens of feet deep. They're the most common erosional agent, and we can find streams everywhere on Earth. Geologic work of glaciers, erosion. Glaciers are the most powerful erosional agents because they can pluck away huge boulder-sized rock from the bedrock of the mountains. Evidence of this are glacial erratics, boulders left behind when the glacial ice has melted. As the glacier flows downhill, it accumulates progressively more rock fragments, which in turn do abrasion to the bedrock under and along the sides of the glacier, leaving behind distinctive glacial grooves. Erosional landform features by alpine glaciers. Landform features formed by glacial erosion or deposition can be organized by the type of glacier that made the landform. We'll start with those found in some mountains formed by erosion from alpine glaciers. The Quaternary Ice Age is responsible for the glacial landform features we see today. Prior to 2.5 million years ago, stream erosion had cut many V-shaped valleys in alpine regions. When the climate became cold enough, winter snows persisted through the summer, and snow began to accumulate at higher elevations. When these piles of snow became thick enough, they compacted under their own weight to become glacial ice, which then flowed downhill to create the glacial erosional landform features. So on this illustration here, we have glaciers. If we follow glaciers up to their head, this is where cirques are forming. Where cirques surround a peak, they can carve out a horn think of like a pyramid-shaped mountain peak. A long, steep-sided ridge between two glaciated valleys would be an arête. If we were to look at a glaciated valley in cross-section, we see that it takes on a U shape as opposed to a V shape, which are formed by stream erosion. If we take the ice away, which has happened over the past few thousands of years, as the climate has warmed, the glaciers have receded, melting away to the very highest elevations. The erosional features are now very clearly exposed. Our cirques at the head of these U-shaped valleys. There's another cirque here, a horn. A lake at the bottom of a cirque is called a tarn. A row of lakes down a glacial or U-shaped valley are called paternoster lakes. Here's our arête, another arête here, another arête here, another arête here, another arête here. Here's the main U-shaped valley, called the glacial trough on here. This one is the deepest because it contained the thickest glacier, which did the most and fastest downward erosion. Because the downward erosion was faster where the main glacier was, the tributary glaciers were left suspended or hanging above the main valley. These contained smaller, less thick glaciers where the rate of downward erosion couldn't keep up with the rate of downward erosion for the main glacier. So we call these hanging valleys, and they can be the source of waterfalls. One of the most famous U-shaped valleys on Earth is Yosemite Valley here in California. The U shape there. At peaks of the last ice age, glacial ice partially filled this valley. At Disneyland, there's an example of a horn, the Matterhorn ride that you might be familiar with, which is modeled after the real thing. This is the Matterhorn in Switzerland. Very steep, pyramid-shaped peak. This photograph has a nice example of a cirque and a tarn. The cirque being this here. There's a tarn and another tarn there. This would be another cirque here. It still contains a small glacier. This is a bit of an arête here. Another arête here. Very steep-sided, narrow ridge with a U-shaped valley in the foreground. This could be a tarn or a paternoster lake. It's hard to tell from this perspective. Yosemite Valley also has great waterfalls, which form because they are falling from hanging valleys. So here, Bridebell Creek falls off the end of the hanging valley down to the valley floor below, creating Bridebell Falls. Big U-shaped valley here with a row of lakes. Good example of paternoster lakes. Fjords exist where glacial ice flowed all the way down to the sea, carving out a U-shaped valley. Then as the glacier and glaciers all over the earth receded as the climate warmed, it left behind a U-shaped valley that then has been progressively flooded by the sea as sea levels rise from the melting glacial ice. Another example of a fjord here. This is a big U-shaped valley. You see the cruise ship in there for scale. These exist along Norway's western coast, as well as Alaska's western coast. Domes exist in Yosemite National Park as well. This is Lambert Dome and Half Dome, one of the more famous landmarks in North America. Big U-shaped valley there. So in review here, pre-Ice Age, during the Ice Age, glaciers actively flowing and eroding, and then after the Ice Age, where we're at today, U-shaped valley, hanging valleys, cirque, cirque, arête, 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 horn, another hanging valley there. When glaciers flow to lower elevations or warmer latitudes, they eventually will melt, depositing their load of sediment called till. Till is typically poorly sorted and a mix of angular fragments. In some cases, the till has been shaped into unique depositional landforms. Two common features that form as alpine glaciers recede are lateral moraines and medial moraines. So here we have a receding alpine glacier. At one point, it appears that the alpine glacier might have extended all the way down to here. And as it's melted, it's depositing its till. The till that was being dragged along the sides of the glacier is now left behind as these ridges of till that we call lateral moraines. So one there and one there. Here's another example of that. There's the glacier. This is all till here, and the till that was along the sides of the glacier are the lateral moraines. When two glaciers merge, their lateral moraines merge as well, and this creates medial or middle moraines. In this photograph, we have quite a few medial moraines, meaning that many glaciers have merged together to form this massive glacier in the foreground. Some common features that form as continental glaciers recede are terminal and recessional moraines, drumlins. Look at some of these features in these illustrations. So here's the glacier, and after the glacier has receded, these depositional landforms have been left behind. We have drumlins, kettle lakes, recessional and terminal moraines, and eskers. So drumlins are asymmetric, low, elongated hills. Sometimes they're described as being cigar-shaped. They will have a steeper and a less steep side, hence asymmetric. And this is useful because the steeper to less steep side indicates the direction of ice sheet flow. So as the continental glacier flowed over the landscape here, we know that it went in this direction from left to right across the screen. The steeper side indicating the direction from which the glacier came or flowed. These often occur in groups or fields. They're called drumlin fields. And they show up nicely on topographic maps as low elongated hills with a steeper side where the contour lines are more closely spaced and a less steep side. Steeper side, less steep side. steeper side, less steep side. So this would tell us that the glacier flowed from north to south. And that makes sense because it would have flowed from colder places in the north towards the south before eventually receding. Here's an esker, long, snaking, low hill. These also show up nicely on a topographic map. There's a long, low hill. And if we go back to our illustration here, we see the esker here and here. Let's connect that to the glacier. And that would have been forming here and here. So they form from glacial stream deposits. These streams flowing out of the glacier are loaded with sediment. So as the stream slows down or it exits the glacier, deposition happens and eskers can form. And then our terminal and recessional moraines, these form where the glacier stops flowing, or it stops advancing, I should say, and the glacial ice continues to flow, bringing more and more till towards the toe of the glacier, where it piles up in these low hills perpendicular to the direction the glacier was moving. Okay, that's it. There is more to this that you are going to pick up in your textbook and lab book reading and through doing the exercises. Thanks for listening.